Hope all you Saintsmen are well. Here's lesson 1.5 on rewriting equations and formulas. I want you to, you're going to get the following directions, which is to solve a literal equation. I don't want you guys to really get bogged down too much about the directions here. So I'm going to solve this literal equation for the variable y. Effectively what we're doing is we're doing this to rewrite, or to do as some mathematicians refer to as symbol manipulation. But we're going to restructure an equation in terms, to be equal to y. So we're actually not solving for a numerical answer here. Okay? Don't worry about those directions. Effectively, it's this. I want you to get y by itself. Now, the challenge here is to look at this equation and say, well, what's being done to y? Well, it's being multiplied by -7. Also, there's this term 4x, which is, you're subtracting 7y from, or effectively it's, you could also consider it's being added to that right side. So you have to remember the inverse order of operations, right? There's the order of operations, but we're going to go in the reverse order when we do the inverse operation. So here, rather than dealing with that multiplication first, and then the addition, we're actually going to deal with the addition first. So we're going to get that y by itself first by moving that 4x off of the left side. Your 4x and minus 4x are going to cancel, and we're left with, on the left side, -7y, which is equal to the sum of 12 and -4x, which is just 12 minus 4x. It doesn't matter which order you write it in. You may write it as -4x plus 12. It's the same exact thing. And of course, now we're still trying to get y by itself. Well, what's happening to y? It's being multiplied by -7, so we are going to divide by -7. All right. -7 and -7 do not cancel, they factor. It's a critical difference, or it's a critical detail, right? It doesn't go away, it's technically just 1. So we have y now by itself, and then we have this entire thing that we had, 12 minus 4x all over -7. And this is the solution to our literal equation. We're done. So rather than writing those directions that you're going to find in your problem set, I'm just going to reiterate what we're really doing here. So we're going to try to solve for y here. So let's take another one of these. This one's a little bit more straightforward. We have 3y, let's write that in black. 3y minus x is equal to 9. Okay, so to get y by itself, we're going to add x to both sides. -x and x are going to cancel. I'm going to have 3y by itself on the left and have 9 plus x on the right. It's being multiplied by 3, so I'm going to divide by 3 on both sides so that I can factor out that 3. And now y is equal to, and here's where some students are going to make a mistake. They're going to write, oh, it's 3x plus, it's going to be 9 divided by 3 plus x, and that is incorrect. Gentlemen, sidebar, remember, you can't do that. If I have 5x plus 10 over 5, I can actually divide both of those terms. I have to account for each individual term. I have 2 terms in the numerator. But if I had just x plus 10 over 5, again, I'm accounting for each of those, but 5 does not go evenly into that coefficient. So this guy's just going to stay the same. So back to our problem we're doing, this is really just going to be 9 plus x, or x plus 9. You can write it in either way, and that's going to be over 3. Next, we're going to solve for w. This is a little bit trickier here. One of the tricks that we're going to use is that we're going to, and let me give you guys your equation here. It's going to be 3w plus 4wp, and that's equal to a. We're going to collect any term with a w on one side. Luckily, in this problem, that's already done for us. All the terms with a w in it are right here, 3w and 4wp. In order to get w by itself, what we can do is we can factor out that w. So the w is going to come out. All right? We're going to take a w out of the term 3w, and we're left with 3. We're going to take the w out of the term 4wp, and we're left with just 4p. Okay? Now, we need to get that w by itself. So, since it's being multiplied by that entire quantity, we can actually divide by that quantity 3 plus 4p. And of course, whatever we do to one side, we have to do to the other. But watch what happens. This entire quantity will factor out. What's left on the left side is the w now by itself, and then we need just to rewrite our entire thing. So we have a, and that's over 3 plus 4p, which we're going to leave alone because there's nothing else that we can factor there. All right, let's solve for x now. So we have y is equal to 3x plus 5xz. Now, all of our terms with the x in it are all on the right. We don't need to do any manipulation. All we now need to do is come down here. So we have y is equal to, and we're going to factor out an x from that entire right side, from both of those terms. So we're going to pull an x out. Let's watch what happens. Pull the x out of 3x, and we have 3. We pull the x out of 5xz, and we have 5z. Okay? If you don't believe me that this is actually a thing you can do, factoring, right? Just redistribute, right? And look at what the result will be. X times 3 is 3x. X times 5z is 5xz. So it's the same exact thing effectively. But now our x is all on its own, and we can actually do that same thing and divide by the entire quantity, of course on both sides, and factor it out. So what are we left with? We have a y over 3 plus 5z, and that's equal to x. Work with you with a surface area problem. Ready? We have s is equal to pi times r squared plus pi r L. It's the surface area of cone. Okay? Doesn't matter. Our directions are going to be to solve for pi. Now, I want you to know that pi does not equal 3.14. That's an approximation, right? That's different. It's almost 3.14. It's very close to that, but what it's equal to exactly is pi. Pi is equal to pi. So let's go ahead. We have a pi in both of those terms. Let's factor that guy out. So pull out the pi. Pi pulled out of pi r squared is just r squared. Pi pulled out of pi rl is just rl. These guys can't be combined because, right, you have an r squared and an r. Those are two different things. So now, same process. Let's divide by that quantity. R squared plus RL. R squared plus RL. Okay? That factors out. And now pi on the right side is by itself, so we've effectively solved, right? S over R squared plus RL. And that's your answer. Okay, let's take the area of a circle. Area is equal to pi r squared. This time, rather than solving for pi, let's solve for r. Step number 1. Let's get the r by itself, right? That's the idea. So what are we going to do? Well, it's being multiplied by pi, and it's being raised to a power, right? Exponent would go first, then multiplication in the order of operations, but the inverse operation, reverse order. So we're going to divide by pi to get rid of that guy. Okay, it factors off of the right side. We have area over pi is equal to r squared. Now, this is a review thing. How do we undo squaring something? Well, that's by taking the square root. So we are going to take the square root of both sides. The square root of a square is just the variable by itself, or the number by itself. So in this case, it's just r. And the left side, we really can't do anything with it. It's just going to be the square root of a over pi, and that is what r is equal to. Consider the following. What about distance? Where distance is equal to rate times time, let's solve for r again. This is going to be a quick one. But this is a common thing that's going to come up in our coursework this year, right? Distance equaling rate times time. You're going to encounter that a lot in physics. Get r by itself, well, it's being multiplied by t, so it's just divided by t, right? That t factors out, and our r is equal to capital D, distance over time. You may be familiar with the following. C is equal to 5/9 times the quantity F minus 32. This, of course, you probably know as the conversion from Fahrenheit to Celsius. So here, we're going to go back the other way, and we're going to solve for F. Well, think about what's being done here, okay? We have C is equal to 5/9 times the quantity F minus 32. Now, I don't want you to think of this as multiplication then subtraction and then add the F minus 32. We have a grouping symbol there, right? In the order of operations, that's the first thing we would handle. So in this case, it's going to be the last thing. So we have to undo 5/9, meaning that we're going to multiply by 9/5, right? Because when we do that, the 9s are going to factor out, the 5s are going to factor out, and we're going to have here 9/5 C equal to F minus 32. Okay? Getting the F by itself, we're going to add 32 to both sides. 9/5 C plus 32, and that's going to be equal to F. Our last problem for today, saying that you're going to deposit $3,500 in an account that earns 4% simple interest, which is not something to be too concerned about. It just means that that's a straight interest calculation. But interest, I hope you know or will learn, is annualized, and it is compounded. So how long will you have to leave the money in the account to earn $350 in interest? Let's go ahead and just correct that. Well, interest, the interest earned, is going to be equal to P times RT. And this, let's actually explain what this is. P is the principal. What principal is that's going to be your initial deposit. People see interest rate and they think that's I. No. That's your interest rate, is R. And of course, T is going to be time, but it's in years. So, we need to get the T by itself, right? Well, that's a pretty quick one. Watch this. We're going to divide by P and R at the same time. Why not? Right? I can actually factor both of those at the same time. So I is equal to P over R, and that's equal to T. So this is going to make our problem pretty straightforward. Our interest earned is $350. Our principal is $3,500, and our interest rate is 4%, which you should know is 0.04. Okay, and that's what time is equal to. 0.04 times 3,500 is going to be 140, so this is 350 over 140, and that's T, so time in years. You divide that, it's going to be 2.5, and that's 2.5 years would take you to earn that much interest. Saintsman, and for the record, 4% is an incredible interest rate. It's a very good one for an investment, especially if you're using a large deposit. The only thing, though, is if you're annualizing that, getting 4% over 2.5 years, right? That's going to be a significantly low percentage. I hope that was sufficient for your problem set. If you have any questions, feel free to email me. Go ahead and get started on section 1.5. Good luck.